6-2 using an activity. So your directions are, you need a pencil on your desk, you need all your books tucked underneath your desk, and then you need to go ahead and find your red workbook, the practice report journal. Go. Go grab it. Alright, so you should have cleared your desk, you have your practice and record journal and a pencil. I'm going to give you a number, please remember it.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Your partner and you have a sum of 14. Find your partner and sit next to them. 7, come and see me.
Who's 2? Who's 9?
Who's 1?
Find your partner, go.
You're 9.
Okay, you need to find your partner.
Oh,
This is
yeah.
11.
Because I was 5 and you're 9 and
I didn't know how to do that.
what number are you?
Oh,
So your partner's 1.
Have a seat next to your partner, let's go. Anywhere you want with your partner.
Way to go, Jeff.
Alright, so go ahead and open up your practice and record journal to activity 6-2. Nope, activity 6-2, it's on page 117. You and your partner, our goal today would be to get through all 3 activities, but I want you to go ahead and check in after the first activity. There's 2 things that I want you to remember when working through this activity. You and your partner will be handed sticks, if you're stuck, to ask questions. The math practice we're working on today is reason abstractly and quantitatively. So your focus is going to be, I can use reasoning habits to help me contextualize and decontextualize problems. What that means is, I can take numbers and put them into real-world context. I can take numbers out of the context and work mathematically with them. All right? So while we're going ahead and doing this, all right, I want you to be thinking, how am I going to go ahead and reason abstractly and quantitatively? What is the essential question at the top of activity 6-2 that by the end of all 3 activities, you should be able to answer? All right, tell me what the essential question is.
How can you order numbers that are written as fractions, decimals, and percents?
So your goal by the end is to be able to answer the question, how can I order fractions, decimals, and percents? All right. Okay, so you and your partner, I want you to go ahead and start on activity 1. I want to hear you talking. I want to hear you discussing. This is not a think, pair, share. This is a work together. All right?
How weird it is because we can give it to like this.
Because 7 over 100 would be...
More than
Okay, I don't hear you guys talking very much. Tell me what you're doing.
yeah.
Okay, you're not. We're doing the activity, which is right here. Okay, this is the essential question we just read. So, what is the directions asking you to do? So I need to know which one's more common, a percent or a fraction, in the first one, and then you have to figure out which one is greater. Are you guys reading this part of the directions? 11%. It says figure out which one is more common. Okay, I don't hear you guys talking as much as I'd like, so tell me what you're doing. So you're comparing, you're taking your 1/20th and moving it into a fraction or a percent. So 1/20 is 5 over 100. 7% is 7 over 100. So which one is greater? Okay, I love it. Keep going. You're doing great. Make sure you pay attention to the direction. Which one is more? Okay, she doesn't get that figured out. Do you know how to figure it out? Okay, tell me what you've done so far. All right, let's go back to the first question. All right. Are you okay with the first question? Okay. So tell us what you did in the first question. All right, so you changed 1 over 20 to 5 over 100. So you knew that 7 over 100 was bigger than 5 over 100. Okay? So you changed them both to what?
Because one is
Alright,
20.
percent or something out of 100, okay, so let's talk about this one.
But we could say
Now
it's like 0.60, so then 12 and 5, 6.
What do you, okay, so can you change,
12.6 is greater.
12,
and
can you change that fraction to a decimal? Another way?
Great, so you do 95.
Do you know what the percent or decimal is for 1/3?
7.
33, you know it too, okay, so what, it's 33, but it's really not just like 33, what's happening? It's third meaning, it's really 0.3.
So 0.
So why don't you go ahead and use that to figure out
Plus
this?
5 is 6.25. Then you just add 2 that to get 250, 875.
Okay, guys, tell me what you're doing now. Okay, tell me which one you're having a hard time, why is C so difficult? So what else could you do? If you can't do 100 using a fraction, what else can you do? Yeah, how do you do that? Do you? Do you? What do you do if you don't know? Alright, if you do 8 divided by 5, that's asking how many 5s are in 8. How many 5s are in 8? 1, so you know your answer's going to be more than 1. And if you look at 5 8s, what do you know about the decimal? Is it more than 1 or less than 1? Less. So the way you tend the division problem wouldn't work because it'd give me a number that would be more than 1. And I need a number that's less than 1. So rather than doing 8 divided by 5, what could I do? 5 divided by 8. Do either one of you have a calculator? Okay, you can go ahead and use it. Alright, you could do the long division, but that's not the point of the activity, so go ahead and just type in 5 divided by 8. Alright, I'm going to have you stop where you are. And if you didn't finish, you're totally fine with that. Okay? So go ahead and put those pencils down. Alright, girls, I think you're the ones that are finished with everything, so you're going to present to us. Alright, so the math practice we're focusing on now. I left my math practices over there. Alright. Un momento, hold up. I can critique the reasoning of others, alright? So right now you are listening to them, go ahead and explain how they got their answers and go through what their steps. You're going to do this by listening. You're going to go ahead and raise your hand if you did it a different way. If they've made any mistakes, we're going to need to let them know. And you're going to ask questions if you need something clarified. Alright? Girls, go ahead.
Alright, so for letter A, we know that a percent is out of 100, so we made 7 over 100, and then 1/20th is equal to 0.5, and so it's 5 over 100, and then we know that 7 over 100 versus 5 over 100, 7 over 100 is first, so 7% is greater.
So you guys change them both to
Fractions.
fractions, okay? Did anyone do it a different way? What'd you guys do?
Oh, we just converted and we turned them into percents.
Okay. Is it really that different? If they turned it into percents and they wrote it over 100?
No.
Talk to your group and figure out why is that pretty much the same thing.
Well, because it's just like, because percents is just like,
Why?
percent sign and then
But how?
equally that.
What's true about percent? Alright, what'd your group come up with? They did fractions with hundreds in the denominator. They did fractions with hundreds in the denominator, and this group did percents. How was that kind of like the same thing? What'd you and your group talk about? What'd you guys come up with?
I didn't really say this here because I just realized if you use the decimal,
Okay.
you realize that they're actually the same thing.
They are the same thing. A percent is out of 100. So those two first examples, they're out of 100, so they're really the same thing as a percent. can you guys explain letter C, because that was one that some groups struggled with. Explain how you knew which one was more common, and then explain what format you took and which one was greater.
So for C, we had to take a fraction quiz where we made fractions in terms of inch decimals, and so I know that 1/8 is 1.25, and so we just multiplied 5 by 1.25 to get 0.625, and so then we just turned that into a decimal, and then 3.75, and then so because of that, we know that 5/8 is greater.
All right, even if you didn't finish, we're gonna move on now to activity 2. All right, so you're gonna continue to work with your partner, and they're gonna ask you to go ahead and order the following numbers. So let's get working on activity 2.
Alright. Okay, so we have to order the numbers.
What do you mean?
Oh, no.
Okay, so but what's their relationship? So how are they related? Talk about it. I'll come back.
Oh, there's.
Talk about it.
None of them are. Oh, wait.
All right, go ahead and read this question.
Oh, wait, percents are.
Okay, so let's look at one of the ones that you changed. So let's look at 11%. What is the relationship between 11% and 0.11 or 11 hundredths?
Less than 1. No, less than 1.
What's the relationship?
Okay, so that's not.
I want you to talk about it over the next.
What's 5 plus 6? They're all less than 1. Yeah.
Oh, okay, that's a good one. What else?
Oh,
Tell me the method you're gonna use to compare them. So what could be true about all of the quantities that are listed? They all could be. Are they all? But could they be?
Oh, fractions.
Oh, good one.
Oh, 5 divided by 6.
Are you number 2? Yeah. Great, go to 3. All right, what's the relationship between 11% and 11 hundredths? How are they the same? How are they different? Okay.
So with 11%, we have 8.8.
Okay. What do you think? How'd you change one to the other? How'd you change a percent to a decimal? Okay. So the value, which was bigger, 11% or 11 hundredths? So what's bigger, 5% or 0.05? They're the exact same. Why is 11% and 11 hundredths the exact same?
Make sure you write it as 7.
Yep.
3.3%.
Right, now all we have to do is just put these in order.
They're both out of 100. So when I'm saying which one is the greater one or which one is bigger, I'm kind of asking a trick question, because does it matter if it's in a percent or a decimal and a fraction? It represents the same amount. Let's look at the next one. So let's look at 0.172 or 172 tenths under thousandths. If I make that into a percent, it's 17.2%. They both represent what?
But I don't know if we have.
The same amount, but what's different about it? One
So
is
we have that
a,
plan for Friday.
one is a decimal, okay? So when you're looking at these quantities, I'm asking, it represents the same amount regardless of the form that they have. I want you to be able to go ahead and move them and then compare them, okay? So the relationship between the quantities is they all can be written as fraction decimal percent. 11% and 0.11 is the exact same, okay? Great, go ahead and move on to 3. When you're going ahead, we have a new group up. So our focus is going to be going ahead and work on the math practice, construct viable arguments, and critique the reasoning of others. So as a class, you're responsible for critiquing how they're figuring things out by listening, comparing arguments, figuring out if they messed up anywhere, and then asking questions if you need anything clarified. All right? So that's your goal. We're trying to critique them. All right, go ahead and work, guys. Tell us what you did.
So, since it asked if we could do fractions, decimals, percents, we decided to do decimals. since if you had a fraction, if it was like 17.2, you couldn't really simplify it, it would be really hard. So we decided to do decimals. So
Did you guys have a disagreement? How did you guys decide? Like, why did you pick percents?
the percents, well, it was the first thing that came off my mind and the one that's easiest to us.
Okay.
So
Could you have done percents?
we could have, yeah.
All right. Does everyone understand why fractions would be a bad idea? He already said it, but can someone else kind of tell us why would putting everything into a fraction probably not be the best idea here? Okay, talk to your group about it.
Because we wouldn't have a common denominator. Because if we're doing fractions, you have different denominators. Right. But then if you put them in decimals, you know that it's all out of powers of 10.
All right, Mr. Gleason's got it. All right, what do you got? Why fractions not a good idea?
Because they probably wouldn't all have the same denominator.
And then what would you have to do to compare those fractions?
Try to get them all the same denominator.
Yeah, so how many of you use decimals and turn them all into decimals? How many of you use percents? All right, what'd you guys do? You changed them all into what? As you were working, what'd you do? Decimals and the percents, okay. All right, and you were able to compare a percent and a decimal just by looking at it too? I like that as well. All right, go ahead, keep going, guys.
So since we did the decimal, we decided to figure out all the fractions and percents, what their decimals were, and then we decided to put them on the line as their original place. So if it was 1/8, which is 0.125, we would have to write it as 1/8 since it is its originality.
Okay. We're gonna now move to activity 3. Activity 3 is war. All right, so we have cards for you. Please be very careful with these. All right. So you're gonna need these cards for you and your partner. You're gonna do a 3-way war game. I have no idea how that works, so I'll come on over and help you out with that. All right. So everybody, come grab your cards now, and go ahead and read the activity and use those cards. We're gonna play some war. Okay, how did you know immediately that she knew? Oh, very good. Okay. All right, go ahead. So what do you do when it's equal? One card down and one card up, just like the right. One card down. And then this card, whoever wins this one's gonna get all of them. No. Put those down, put the next one up.
So 20 cards each face down, I guess.
Which is more, 3/9 or 0.58? How do you know that? She doesn't know. Tell her how you know. Okay. What would this be as a decimal?
How many are there?
You didn't know that from before.
What's this?
What is it?
So there we go.
All right.
Keep going back and forth. Come to each.
Wait.